All right, guys, so today we're talking about counting and probability. And we're going to really be focusing on the counting part. We'll just throw in a little bit of probability with a few questions. But what we're talking about counting is, let's say we're looking at this California license plate. And let's just simplify things to start with and say that in a California license plate, there are 7 different numbers. And the first number, you have 10 choices because it could be 1, 2, well, let's get this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, or it could be 0. So you have 10 different choices for this first number. Well, because it's a license plate, it doesn't matter if you have the same number twice in a row. So you also have 10 choices for the second number, 10 choices for the third, for the fourth, for the fifth, for the sixth. So all 7 of these, you've got 10 different numbers that you're choosing from. So if it were to ask us, like, how many different license plates we could come up with, well, you've got 10 choices for the first number, 10 for the second, 10 for the third, 10 for the fourth, the fifth, the sixth, and the seventh. So rather than making that great big tree, we just can use that counting principle where I've got 10 choices for each. So when I times those all together, I end up with 10 to the 7th power, which gives you what? 7 zeros. 1, 2, 3, 4, 5, 6, 7. That's a lot of choices, just that alone. That gives us what? 10 million different license plates that we could come up with. Now, if we are looking at a little bit more, let's say instead of just numbers. So example 1 right here has how many 7-character license plates are possible if both numerals and uppercase letters can be used. Well, there's 10 numbers that can be used, 1 through 9 plus 0. And uppercase letters, there's 26 letters in the alphabet. So instead of just choosing out of 10 numbers, now we're choosing out of 10 numbers or 26 capital letters. So that gives us a total of 36 choices for the first digit. And then I can have 36 choices for the second and 36 for the third, because it doesn't matter if I repeat. So what we end up with, if we keep going, is 36 choices for all 7 spots. So if we do 36 raised to the 7th power, and it's going to give us to us in, let's do 7, 8, 3, 6, 4, 1, 6, 4, 1, and it wants e to the 10th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you look at what, 78 billion choices for license plates, that's how many different possible license plates we would get. Then if we go beyond that and say, how many 6-character passwords? And this will kind of give you some insight as to why passwords are set up the way that they are. But we got 6-character passwords. So 1, 2, 3, 4, 5, 6. And you can combine lowercase letters. So there's 26 of those. Uppercase letters, there's 26 of those. Numerals, 10 of those. And these characters, the at, the dollar, the, what do you call that? Exclamation point, our star, and the and. So we got 1, 2, 3, 4, 5 more options here. So we've got 26, 52, 62, 67 different choices for that first option. And then 67 different choices for the second, and 67, 67, 67, 67. So we've got 67 different characters to choose from in all 6 positions. So if I do 67 raised to the 6th power, because I'm going to do 67 6 times, now this time we've got what? 9, 0, 4, 5, 8, 3, 8, 2, 1, 7. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So that's 90 billion different passwords, which would make trying to hack this password pretty difficult if you're trying to guess from 90 billion different possibilities, okay? So that means the correct password, there's only one out of these 90 billion that are correct. It makes it a little bit harder to hack a password when it has so many different characters to choose from, which is why when you make a password, it makes you choose a lowercase, an uppercase, a number, and sometimes they'll throw in one of these symbols. It just creates more, it makes it harder for people to hack your password. Now, what if instead of just simple repeating situation, what if we have what's called a permutation? So one of the examples here says that you coach a team of 4 swimmers. How many different ways can you order these swimmers in a 4-person relay? Or in other words, I've got 4 swimmers that I'm choosing from, and they're going to do a relay race. Well, the first racer could be one out of those 4 people, but the second swimmer can't be the first one that I chose. It can only be the 3 that are left. And then my third swimmer has to be chosen from the 2 that are left. And my last swimmer is just whoever's left over. So instead of doing 4 times 4 times 4 times 4, because the order of my swimmers matter and they can't repeat, the same swimmer can't swim twice, then we get 4 times 3 times 2 times 1. And we call this a permutation. So if the order of our choices matter, so if order matters, and if there's no repeats, then we use what's called a permutation. And permutations are nice because instead of just doing 4 to the 4th power, all we do is 4 factorial. So on my calculator, I would do 4. And then if I didn't want to do times 3 times 2 times 1, we can use the factorial button, which, where is it on this calculator? Is it going to be under math? 4 factorial is going to be, no, probably under test. Maybe. Nope, not under test. Let's find it here. There it is. So under probability, factorial, it's number 4. So if I do 4 factorial, I get 24, which is the same as doing 4 times 3 times 2. Nope, not times decimal, times 2 times 1. Same answer. So we would say that there's 24 different ways that this coach can have his racers line up to swim this relay. Okay, so example 2, class schedules. A middle school principal needs to schedule 6 different classes, algebra, English, history, Spanish, science, and gym, in 6 different time periods. So how many different class schedules are there? So you've got to take algebra, English, history, Spanish, science, and gym. How many different ways can those classes be scheduled? So if you took one of the 6, you've got 6 to choose from, but then you only have 5 to choose from after that. And then you only have 4 to choose from, and then 3, and then 2, and then 1. So this would be a permutation. So I could just do 6, and then I go to math over to probability and down to factorial. So that means there are 720 different ways that these classes could be scheduled. There's 720 different orders that you could take your 6 classes in because you can't repeat, and it matters what order you take the class in. Now, what happens if example 3 right here is a little bit different of a situation? And let me move these out of the way a little bit. So what happens if you have 12 candidates running for 3 positions? Okay. So the top vote getter becomes the mayor. The second most votes becomes deputy mayor, and the third most votes becomes treasurer. So it wants to know how many outcomes are possible for the 3 leadership positions. So we're choosing from 12 people, but we're only choosing 3 out of those 12. I'm not ordering 12 people. I'm only choosing 3 out of those 12. So my first choice, there's 12 different candidates I can choose from. And then there's 11 different people left to be the second choice. And then there's 10 people left to be the third. But that's it. I'm only choosing 3 positions. So I'm only doing 12 times 11 times 10. And order still matters because whoever gets chosen first becomes the mayor. Whoever gets chosen second becomes what they call it, the deputy mayor. And whoever's third becomes the treasurer. So it does matter which order the 3 people are chosen. If it was like a committee where the order doesn't matter, that would be different. But this order matters. So there's a couple of different ways you can do this. You can just do 12 times 11 times 10. I can just stop there. I've got 12 choices, then 11 choices, then 10 choices, which gives me 1320. Or, because really what you're doing is you're getting rid of the rest of them. We can't just do 12 factorial because I'm not ordering everybody. I'm just ordering the first 3. So the way the formula works, there's a couple of ways that we can do it. We can just times these together. You can use this formula right here, NPR. This is called a permutation. N represents the total number of people we're choosing from. R represents how many that we're choosing. And in this case, you would do 12 factorial, but then you would have to divide it by the 12 minus the number that we're choosing factorial. So this would have to go on the bottom. All right. So that would give me my 1320. Or on our calculator, we have this button right here, NPR. If I go to math and I go over to probability, you'll notice right here, NPR. If I choose that one, it wants a number in front. Well, N comes first. So out of 12 people, I want to choose 3 of them. So I would do 12 and then that P's there and then 3. And that also gives me 1320. If you're using one of the older TI calculators, sometimes you have to do 12 first and then you go over to NPR and then hit 3. It doesn't put those there for you. You have to actually put the 12 first. And then what it would look like on your calculator, you would put a 12 and then you would have the NPR and then you would put a 3. And it would give you the same thing. You'll get the same 1320. So that's when we're choosing out of a group of people, but we're only choosing some of them and the order of them matters. So like example 4, if batting order. So you have a league manager that has 15 children on the team. How many ways can she form a 9-player batting order? So order matters because it matters if you bat first or second or third or fourth. And out of 15 children, we're only choosing 9. So I would do out of 15 children, I'm going to choose 9 of them and put them in order. So look at how many different ways that this coach could have a batting order. What is that? 1, 8, 1, 6, 2, 1, 4, 4, 0, 0. So that's 1 billion different ways that she could order these children in a batting order. That's almost 2 billion different batting orders that this coach could come up with. That's a lot of batting orders, okay? So again, the order matters and there's no repeating. We would use these permutation formulas, all right? Now, a combination is when you still can't repeat. So we still have this situation where there's no repeats. But in combinations, the order does not matter. Does not matter. Okay? Permutations order matters. In other words, the mayor is the one with the most votes, or the batting order matters. In this ice cream combination problem, you're going to select 3 different flavors of ice cream out of 12 flavors. But if I choose vanilla, chocolate, and strawberry, that's the same as choosing chocolate, vanilla, strawberry. That's the same as choosing strawberry, vanilla, chocolate. The order doesn't matter because I'm just choosing 3 flavors. The order doesn't matter. And in that case, we call this a combination. And the difference here is we've got to get rid of all these VCS and CVS and SVC. All of these are getting counted more than once if we had just done our NPR. So if you notice in the formula, it's just the NPR, but then it divides by the number of factors we're choosing, factorial. So since I'm choosing 3 different flavors, the way that this would work is I would do n factorial on top. And then because of our other NPR formula, we've got the n minus r factorial on the bottom. But the combination has us divide by r factorial. So if I did my NPR for this case, I've got 12 flavors of ice cream. And I'm going to do the NPR, and I'm choosing 3 flavors. But it doesn't matter the order I choose them in. So I would divide that by r factorial, which is just 3 factorial. So I would get 220 different combinations of ice cream because the order doesn't matter. Now, rather than just like this NPR, if you don't have a calculator, you can do n factorial divided by n minus r factorial. That was just 12 factorial divided by 12 minus 9 factorial, which becomes 12 factorial divided by 3 factorial. Just like that problem, you can just plug the numbers in. Okay, you can do NPR divided by r factorial. So I could do 12 factorial divided by 12 minus 9 factorial. Oh, not 12 minus 9, 12 minus 3, sorry. 12 minus 3 factorial and times that by 3 factorial. Or on the calculator, we have a nice button. If I go to math over to probability, notice the NPR, I also have an NCR. So P stands for permutations, C stands for combinations. So I can choose combinations, and just like before, I can do 12, choose 3, which also gives me 220 different combinations, okay? So you can use your calculator to do any of these. You just have to make sure you use the right formula. So example 6, how many different 5-card poker hands can be dealt from a deck of 52 cards? Now, we've got to be a little bit careful here. Just making sure that you understand what it means by 5-card hands. So when it says 5-card hands, that means that you get, when you're playing poker, you get 5 cards, okay? And let's say, just to make this simple, that this is a heart, this is a heart. Let's just make them all hearts. And this could be a 2 and a 4 and a 6 and a king and an ace. It doesn't matter what order they're in. You just have those 5 cards. The order doesn't matter. So if it wants to know how many different hands I could get from 52 cards, I would say, okay, out of 52 cards, the order doesn't matter. So I'm going to do a combination, and I'm choosing 5 cards. So there are 2,598,960 different hands that you could be dealt in poker. There's 2,598,598,000 different combinations that you could be given. Okay. Then it says, what's the probability of getting one particular hand, such as a royal flush of hearts? Well, there's only one way to get a royal flush of hearts out of 2,598,960 different possibilities of hands, right? There's one out of that many possibilities. So you could put that in you could do 1 divided by this. There's your probability, which is going to be a really, really low percentage, okay? Example 7. Suppose you play a lottery in which the winner is chosen by drawing 6 balls at random from a drum containing 52 numbered balls. What's the probability that your 6 numbers will match the 6 winning numbers? So the numbers don't have to be drawn in a certain order. So this is an NCR. All right. If they don't matter the order, then I would say out of 52, then I would go to probability. I'm going to choose 6. I want to know there are 2, let's see, 2, 0, 3, 5, 8, 5, 2, 0. Those are all the different combinations of 6 balls that could be chosen. If you're only one of those, that's one out of that many different possibilities, then your probability is pretty low. That's, let's see, -8, so 0.0, 2, 3, 4, 5, 6, 7, 4, 9. That's your chance of being the winning probability, okay? And that's if the order does not matter. If the order does matter, like let's say that getting 1, 2, 3, 4, 5, 6, if those balls getting chosen, if it's different than being 2, 3, 4, 5, 6, 1, in that order, if the order did matter, then you would choose out of 52. Order matters so that we would choose NPR instead of NCR, and we're only choosing, we're choosing 6. Then you're even lower probability because you've got 10 more decimals there. So I would do 1 divided by this value. So my probability is going to be 0.0023456789 10 6 8. So look at how much lower probability if the order does matter. Because if the order matters, there's a lot more to choose from than if the order doesn't matter. Okay. So on the homework, on homework, let's see, what are we on? This is going to be 7E. It's going to ask you to choose the appropriate method and then to find how many different choices. So I guess there's a couple of different ways they can ask you questions. If it just wants to know how many different possibilities there are, then you just do your combination, your permutation, or your repeating formula. But if it wants to know what's the probability of something happening, you've got to figure out the number of ways it could happen, and then the one would go on top, okay? What's the probability of winning out of this many different things happening? You've only got one chance of winning out of all the possible chances. So on this homework, you're going to have to choose between a repetition, a permutation, or a combination. All right. You've got to use which formula. Remember, repetition is just the number of times raised to that power. So that was like our license plate. There were 36 different possibilities, and we were doing 7 different numbers. So you do 36 to the 7. Permutation is when there's no repeats and order matters. Okay. Combination is that NCR, and that's when there's no repeats and the order does not matter. Okay, order doesn't matter. Permutations, the order matters. Repetition is when they can repeat, and that's just when you've got 10 choices, then 10 choices, then 10 choices. So you're going to have to pick which one of those methods is going to be the best to use, and then you're going to have to actually use it. You are more than welcome to just plug it into your calculator rather than having to use these great big formulas. And great big, they're not that big. But you don't have to use that formula. You're welcome to just use the NCR button on your calculator. Good luck.